Good morning, everyone. I welcome all of you in the fourth lecture of electrolytic conductivity. In this lecture, we will learn about the specific conductance and equivalent conductance. In last lectures, we have studied about the conductance, then resistance, specific resistance. These points are covered in the last lecture. So in this lecture, we will learn about the specific and equivalent conductance. Now in this slide you can see here what is the specific conductance. We have studied the conductance, that is a reciprocal of resistance, or it is simply capacity of substance to conduct the electricity. That is nothing but conductance. But see the definition for specific conductance. So reciprocal of specific resistance is called as specific conductance. You can see here. So the simple definition for specific resistance is it is the reciprocal of specific resistance is called as specific conductance. It is denoted by K, that is the Greek letter, it is known as kappa. So it is indicated by K. And in this slide you can see here the simple equation for specific resistance, that is R is equal to rho into L by A, where rho is the specific resistance, L is the length, and A is area of cross section. So what is given here? Specific conductance is simple reciprocal of rho. So we can write here for rho, take the reciprocal 1 by rho. So that is equal to R reciprocal, it is 1 by R, and A by L can be reciprocally written as L by A. So in this way K is equal to G into L by A. Now what is G? So it is a reciprocal of resistance, that is nothing but conductance. So you have written here G is equal to conductance. L is the length and A is area of cross section of the conductor. So that is the definition of specific conductance. Now in next slide you can see here the alternate definition for specific conductance. So specific conductivity is also defined as the electrical conductivity of the electrolyte between the opposite faces of a unit cube. So if you look here, there is a diagram for unit cube. So unit cube, I will show here with the help of pen. So you can see here, this one is the unit cube. You can see in this diagram. So it is the electrical conductivity of the electrolyte between the opposite faces of the unit cube. Now you may consider this face that is indicated by red line, and this is the opposite face that is by blue line. So between these two conductors I have shown here, one is anode, second one electrode is cathode. So electrolyte present between these two opposite faces of the cube, that is the unit cube, and the conductivity carried by that particular electrolytes is nothing but the specific conductivity. Alternatively, it can be defined as the conductivity of the material in a cell whose electrodes are, you can see here, whose electrodes are unit distance apart. That means distance is fixed between the two electrodes and they possess unit surface area. म्हणजे त्या इलेक्ट्रोडचा जो सरफेस एरिया आहे तो युनिटी असला पाहिजे, एरिया ऑफ क्रॉस सेक्शन, आणि त्याच्या दोघांमधलं जे डिस्टन्स आहे ते डिस्टन्स सुद्धा युनिटी असलं पाहिजे किंवा फिक्स असलं पाहिजे. तुम्ही त्यासाठी या पुढच्या डायग्राम मध्ये बघू शकता, या ठिकाणी राईट क्लिक केलेलं आहे आणि या दुसऱ्या डायग्राम मध्ये क्रॉस मार्क दाखवलेला आहे, कारण त्या दोन इलेक्ट्रोड मधलं जे डिस्टन्स आहे तर ते जे डिस्टन्स आहे ते या ठिकाणी तुम्ही बघू शकताय. एका डायग्राम मध्ये इलेक्ट्रोडच्या मधले जे डिस्टन्स आहे ते फिक्स आहे, दॅट इज युनिट डिस्टन्स. पण तेच तुम्ही दुसऱ्या इलेक्ट्रोड मध्ये जर बघितलं तर डिस्टन्स जरी फिक्स असलं तर एकाचा जो एरिया ऑफ क्रॉस सेक्शन आहे तो एरिया ऑफ क्रॉस सेक्शन या ठिकाणी बघा हा जो इलेक्ट्रोड आहे तो एकदम छोटा दिसतोय, पण दुसरा जो इलेक्ट्रोड आहे तो मोठा आहे. म्हणजे त्याच्या एरिया ऑफ क्रॉस सेक्शन मध्ये फरक आहे. तर अशा प्रकारची जर एरिया ऑफ क्रॉस सेक्शन असेल तर त्याला आपण युनिटी म्हणत नाही. त्यामुळं जो काही कंडक्टन्स असेल, दॅट इज कंडक्टिव्हिटी ऑफ द मटेरियल इन अ सेल whose electrodes are unit distance apart, ही या ठिकाणी फिक्स होत नाही किंवा ही डेफिनेशन इथे लागू होत नाही, पण या डायग्राम मध्ये मात्र तुम्ही ते बघू शकताय. So in this way, alternatively, this can be defined as conductivity of the material in a cell whose electrodes are unit distance apart and possesses unit surface area. So in other words, specific conductance of a solution is the conductivity of solution of unit volume of the solution. That is 1 cm cube, unit volume of the solution. Now the unit for specific conductance is per ohm per centimeter, or in SI system it is written as Siemens per centimeter. So we will go in the next slide. So now about the equivalent conductance. We have studied specific conductance. Now we will see equivalent conductance. So specific conductivity is a property for specific electrolyte solutions. Now why we can say like this one? Because there are number of electrolytes are present. It may be strong or weak, like NaCl, NaOH, HCl, KCl. So these are the number of electrolytes. But when we study the overall conductivity of all the ions, that means different electrolytes are added in a solution, so that time this property, that is specific conductivity, is specific only for particular electrolytes. Means if you are considering KCl, so it gives only about KCl, so it doesn't think about the any other electrolyte which is added along with the KCl. So it may be NaCl, it may be NaOH or any other. So what we have to do? So it is cleared in second point. It does not provide the overall conductivity value if different electrolyte solution is used, because specific conductance depends upon the concentration of solution. कारण 1 cm क्यूब सोल्युशन असेल तर त्याचा जो कंडक्टन्स आहे तो म्हणजे स्पेसिफिक कंडक्टन्स. तर अशा वेळेस आपण यूज करतो की दिस इज द स्पेसिफिक वन. तर it depends upon the concentration of solution. But now we have to take solution of equivalent concentrations for the determination of overall conductivity of the solution. So now equivalent conductance, how we can define it? It is conductivity of all the ions produced when 1 gram equivalent of electrolyte is dissolved in a VCm cube, that is Cc, VCm cube or V cubic centimeter solution. म्हणजे इक्विव्हॅलंट कंडक्टन्स आपण कसा डिफाइन करू शकतो? असं सोल्युशन ज्या सोल्युशन मध्ये 1 ग्रॅम इक्विव्हॅलंट इलेक्ट्रोलाइट डिझॉल्व्ह झालेले आहेत, तर त्याच कंडक्टन्सला आपण त्याचा इक्विव्हॅलंट कंडक्टन्स असं म्हणतो. सो लॅम्बडा V, इट इज इंडिकेटेड बाय लॅम्बडा V, that is equal to K by C, where K is the specific conductance and C is the concentration of solution in equivalent per liter or equivalent per dm cube. That is nothing but normality N, and K is the specific conductance. So we will go into the next slide. Now you can see here what is the relationship between specific and equivalent conductance. Now specific conductance is indicated by K, equivalent conductance is indicated by lambda V. Now consider any rectangular metallic vessel, just as like shown in this diagram. This is the rectangular metallic vessel having 1 centimeter length, 1 centimeter breadth. So in this way 1 cc, that is the cubic centimeter volume formation, takes place. So now if 1 cc solution is placed in this vessel, so the measured conductivity will be, no doubt, it is specific conductivity, because specific conductivity is nothing but conductivity of 1 cc of the solution, because it is the conductivity of unit volume of the solution. Just you can see here, it is the conductivity of unit volume of the solution. Now, if this 1 cc solution contains 1 gram equivalent of electrolyte, then by definition the measured conductivity will also be equal to the equivalent conductivity. How it is possible? Because just in the last slide we describe equivalent conductance, that is, it is the conductance of solution in which 1 gram equivalent of electrolyte are dissolved. जर का या 1 cc सोल्युशन मध्ये 1 ग्रॅम इक्विव्हॅलंट इलेक्ट्रोलाइट डिझॉल्व्ह झालेले असेल तर त्याच्या कंडक्टिव्हिटीला आपण इक्विव्हॅलंट कंडक्टिव्हिटी म्हणतो. म्हणजेच आता या केसमध्ये इक्विव्हॅलंट कंडक्टिव्हिटी आणि स्पेसिफिक कंडक्टिव्हिटी सेम आहेत. And specific conductivity, it is the conductivity of 1 cc of the solution. Then why it is equivalent conductance, equivalent conductivity? Because that 1 cc volume contains 1 gram equivalent of electrolyte. म्हणून both are same. But you can see here lambda v is equal to k. So this condition is satisfied. Now it is important one. Now if 9 cc pure solvent is added, then what will be the total volume? It is 1 cc plus 9 cc, so totally 10 cc volume. आता 10 cc जर volume झालेला असेल, now see this one is important statement, that is the measured conductivity will be still equivalent conductivity. Why? Even though if volume is increased from 1 cc to 10 cc, quantity of electrolyte is still 1 gram equivalent, because of which the measured conductivity will be its equivalent conductivity. But what the definition says, see into the diagram which is in the next slide. See here. So this is 1 cc solution, आणि जर का याच्यामध्ये 1 ग्रॅम इक्विव्हॅलंट इलेक्ट्रोलाइट डिझॉल्व्ह झालेले असतील तर स्पेसिफिक कंडक्टिव्हिटी अँड इक्विव्हॅलंट कंडक्टिव्हिटी इज सेम, नो डाऊट. जसं की मी आता तुम्हाला समजावून सांगितलं तो कन्सेप्ट, तोच या डायग्राम मध्ये मी सांगितलेला आहे. आता जर या 1 cc मध्ये तुम्ही 9 cc सोल्युशन सॉल्व्हंट जर ऍड केला तर जे काय व्हॉल्यूम तयार होणार आहे ते या ठिकाणी दिसतंय. तुम्ही बघू शकता हे रेड लाईन ने जे इंडिकेट केले ते 1 cc सोल्युशन. आता याच्यामध्ये ऍड 9 cc solvent, so solution become now 10 cc, volume become 10 cc, you can see here. आता हे टोटल 10 cc झालं, पण याच्यामध्ये जी काय इलेक्ट्रोलाइटचं कॉन्सन्ट्रेशन आहे ते 1 ग्रॅम इक्विव्हॅलंट आहे. त्यामुळं 1 ग्रॅम इक्विव्हॅलंट इलेक्ट्रोलाइट डिझॉल्व्ह असल्यामुळे जी काय कंडक्टिव्हिटी असेल ती नक्कीच इक्विव्हॅलंट कंडक्टिव्हिटी असेल. बट नाउ सी बाय डेफिनेशन, volume is 10 cc but still electrolytes are 1 gram equivalent, so measured conductivity is still equivalent conductivity, but specific conductivity does not remain same. And specific conductivity ka, it is the conductivity of 1 cc of solution. Now solution is not 1 cc, it is diluted, so its specific conductivity no doubt decreases because concentration decreases, आणि specific conductivity ही concentration वर depend असल्यामुळे त्यामध्ये आपल्याला डिक्रीज झालेली दिसून येते. So specific conductivity decreases, but now we will calculate equivalent conductivity. So the measured conductivity of solution will be 10 times the specific conductivity. You can see here 1 cc 10 पटीनं वाढल्यामुळे त्याची जे काही इक्विव्हॅलंट कंडक्टन्स असेल तो फॉर्म्युल्यामध्ये दाखवलेला आहे. दॅट इज लॅम्बडा व्ही इज इक्वल टू स्पेसिफिक कंडक्टिव्हिटी इंटू 10. असं का केलं तर स्पेसिफिक कंडक्टिव्हिटी ही 1 cc शी रिलेटेड आहे, पण व्हॉल्यूम 10 पटीनं वाढलं त्यामुळे ओव्हरऑल कंडक्टन्स घेत असताना लॅम्बडा व्ही बरोबर के इंटू 10 असं आपल्याला घ्यावं लागेल. सो नाव इन द नेक्स्ट स्लाइड, सिमिलरली इफ सोल्युशन इज डायल्युटेड 100 टाइम्स, आता आपण 10 टाइम्स डायल्युटेड केलं, पण त्यानंतर जर का आपण 100 टाइम्स डायल्युटेड केलेलं असेल तर नक्कीच लॅम्बडा व्ही इज इक्वल टू के इंटू 100. So in general, if 1 gram equivalent of electrolyte is dissolved in V cm cube of solution, then how we can write lambda V is equal to K into 10 किंवा 100 च्या ऐवजी डायरेक्टली आपण कॅपिटल V लिहू शकतो, that is the volume of solution. So equivalent conductivity can also be defined as it is the product of multiplication. It is the product of specific conductivity and volume of solution which contains, so this word is important, which contains 1 gram equivalent of electrolyte. So this is the complete definition for equivalent conductance. Now we have to determine the value of VCC solution containing 1 gram equivalent of the electrolyte. Suppose C is the concentration in gram equivalent per liter, then concentration per cc is C upon 1000. म्हणजे 1 cc मध्ये C इतकी क्वांटिटी प्रेझेंट आहे, दॅट इज कॉन्सन्ट्रेशन. सो इट इज C by 1000. 100 असेल तर C by 100. So thus in the next slide you can see here C by 1000 gram equivalent is nothing but or is equal to 1 cc solution. Then 1 gram equivalent is equal to how much cc? You can see here C by 1000, that is equal to 1 cc. Then 1 gram equivalent is equal to how much? So you simply take cross multiplication of these two quantities and divide by the left hand side quantity. So it is 1 gram equivalent into 1 cc solution upon C upon 1000. So gram equivalent get cancelled. C by 100, 1000, 1000 will be going to the numerator. So it is 1000 by C. And what is the unit remains? It is cc. So it is 1000 by C cubic centimeter, that is nothing but V cubic centimeter. So putting the value in above equation number 1, which is we have seen in the last slide, that is lambda V is equal to K into V, that is the equation. Put up the value for uh, that is concentration. So lambda V is equal to K into, now put up the value for V, that is 1000 by C, where C is the concentration. So what is the equation now? It is simply K into 1000 upon N, or K into 1000 by C, where this C is the concentration and N is the normality of solution in gram equivalent per liter. So in this way we can define the specific and equivalent conductance. Now we will see the unit for equivalent conductance. Now we have seen the formula lambda V is equal to K into 1000 by N. Put up the values. This one K is the specific conductivity. It is in always in per ohm per centimeter divided by 1000 cm cube per liter, that is the concentration, and normality is in equivalent per liter. So this liter per liter get cancelled. Cm raised to 1 minus 1 and Cm cube. So it is 3 minus 1. It is simply become Cm square. So per ohm Cm square, it goes into the numerator per equivalent. So that is the unit per ohm centimeter square per equivalent, or simply replace per ohm per centimeter by Siemen meter square per equivalent. So that is the SI unit of equivalent conductance. So in this way we have discussed specific conductance, equivalent conductance, relationship between specific and equivalent conductance, and lastly unit for the equivalent conductance. Now in the next video lecture we will discuss about the molecular or molar conductance. So thank you very much.